Hello everyone. In this video, I want to talk about the converse of the Pythagorean theorem. So we know the regular Pythagorean theorem gives us the equation a squared plus b squared is equal to c squared. In other words, the square of the legs of a right triangle, the sum of those is equal to the square of the hypotenuse of the triangle. Now, this theorem is also true in reverse. So the converse of this theorem is also a true statement. So going backwards, if a squared plus b squared does happen to equal c squared, then we know that our triangle is a right triangle. So that's what I want to talk about and how to use that. So here I have a couple of triangles, and what I want to do is I want to test to see if these are right triangles or not. So what we're going to use is the converse of the Pythagorean theorem. We're going to take the three side lengths, we're going to plug it into the equation a squared plus b squared is c squared, and if I end up with a true statement, so if that equation works, then we know we have a right triangle. If it doesn't work, well then we don't have a right triangle. So let's start off with this first one. We have side lengths of 8, 7, and the square root of 113. When we plug this into a squared plus b squared plus c squared, the only thing we need to be careful of is we need to make sure that the longest side goes in for c squared. Remember, the hypotenuse is the longest side of a right triangle, so we need to make sure that the potential hypotenuse, the longest side we have, the longest side that we're given, does go in for c. And the way I'm going to notate this here is I'm going to put a little question mark over my equal sign because we're not sure yet. So we have 8 and 7. The biggest side is going to be the square root of 113. I know that this is bigger than either of these two sides because the square root of 100 is 10. So this is bigger than 10, which is also bigger than 8 and 7. So if we plug everything in, we have 7 squared plus 8 squared. And then again, I'll do a little question mark over the equal sign. And then we have the square root of 113. And we are going to square that. So going through, following our order of operations, we'll square everything. 7 squared is 49. 8 squared is 64. And then on the other side, when I square a square root, these are inverse operations, so they just undo each other, and I'm just left with 113. On the left-hand side, let's add these together. So 49 plus 64, we do end up with 113. And that's what we have on both sides of our equal sign. So because this does work, because we end up with a true statement, this does mean that the converse of the Pythagorean theorem works, which means that this is a right triangle. So the square root of 113 is our hypotenuse, so that is a right angle across from that. Let's try one more, just to go through that process one more time. So here we have sides of 15, 36, and 4 times the square root of 95. So again, we want to plug all of that into our Pythagorean theorem to see if it works. 4 times the square root of 95, that's going to be our biggest side. This is a little bit less than the square root of 100. So the square root of 95 is a little bit less than 10. So 4 times a little bit less than 10 gives us something that's a little bit less than 40, which is bigger than 36. So that is our longest side. So we have 15 squared plus 36 squared. And then on the other side, we have 4 times the square root of 95 squared. All right, now squaring everything, 15 squared is 225. 36 squared is 1,296. And now on the other side of our equal sign, I have a little bit of multiplication separating the 4 and the square root of 95. When I square this, I do need to square both parts in here. So I'm going to square the 4, and I'm going to square the square root of 95. So 4 squared is 16. And then, just like we had in our first example, these inverse operations undo each other. So we're just left with 95. Okay, on the left-hand side, adding these two together, we end up with 1,521. And then on the right-hand side, 16 times 95, that is going to be equal to 1,520. So really close, but the two sides of my equation are not equal to each other. So the converse of the Pythagorean theorem doesn't work. So our triangle here is not a right triangle. Okay, so that's how we use the converse of the Pythagorean theorem. So we take the three side lengths of a triangle, we'll plug it into the equation a squared plus b squared plus c squared, and if it works, we have a right triangle. If that equation doesn't work and we end up with something different on both sides of our equation, then we know that we don't have a right triangle.